Okay, this is our explanation of how to factor and use the zeros to sketch this function. The first thing we're going to do is figure out the factors of P and Q. So we're going to write them as a set. Just as a reminder, you don't have to do this every single time. This is just the list to help us figure out what we're going to start checking first. So you don't have to write it the way you just did on the last question as just the factors of P and just the factors of Q. You can put them together now that you're sort of used to how to do it. And my advice is to always put the whole numbers first. So, and 7. So we're looking at the factors of the 35 divided by the possible factors of 9, and we end up with this list. And when you're doing the list, you don't have to keep going unless I specifically tell you to. So it is fine just to do something like that with a dot, dot, dot. Okay, so the next thing we're going to do is start going through the list and checking if they're factors. What you actually need to write down is just this part. You're just going to say F at 1, F at -1, like so. And you're going to go through the list of factors. You don't need to actually write out the whole equation every time. You're just going to use your calculator and plug the number in, and every time you're looking for 0. So you're just checking them until you get to 0. Every time you do this, 1 and -1 are the first two things you're going to check. So always start with the easy ones and just keep going. And it turns out, once you put this in, that F at 1 does equal 0, which tells you that it is a factor. So we don't even have to check the rest. So right off the bat, we know that x minus 1 is a factor. So we are going to start by writing our original. And we're going to factor out x minus 1. If you look at the previous example we did a little factoring one, and we were told what we could factor out. Here we had to figure it out. So we figured out that x minus 1 is one of the factors. The reason we use x minus 1 when f at 1 was equal to 0 is that 1 was the number that made the factor equal 0. So you always have to switch it, go back, sort of go backwards. So x minus 1 times what gives us 9x cubed. Our strategy for this is going to be to use synthetic division. So we're going to just come to the side of our page and do synthetic division with a 1. And at this point, you're quite good at doing synthetic division, so it's just a sort of procedural thing. That was 41. When you do the synthetic division step, this is a very nice part of the process. So if you made a mistake here and were wrong, that it doesn't actually equal 0, that would be immediately evident when you did synthetic division because you wouldn't get 0 as the remainder. So if you don't get 0 as the remainder, you need to go back and just double check your synthetic division and double check what you did over here. So you want to make sure that that matches up. So that makes us happy if you get 0 as the remainder because it means you did the previous step correctly. Once you figure out your synthetic division, you're going to come back and write it with your original equation. And you're going to repeat that process, if necessary, until you get to a quadratic. And in this particular example, it's already a quadratic. So now you can factor that using whatever strategy you like for factoring a quadratic. For most of you, I think you use man. So use that strategy and factor this. But if the original had been x to the power of 7, you would have to keep repeating. So you're going to now have a new function. Check if there are any factors of that. Start with your list of P and Q. Do synthetic division again. Figure out what one will come out of that. So it is a big process. Typically, they're only to the power of 4 or to the power of 5, but there are a couple that are going to come up that are even higher. So once you get to here, this can be factored using man into 3x plus 7 and 3x minus 5. If you need to review that, that's fine. Just remember it's using decomposition and man, and that's a strategy you do already know. This tells us the locations of all of our zeros. So now we know that there is a 0 at 1, at -7 over 3, and 5 over 3. And if you look at the original question, we were actually asked to sketch this. So we're going to put a really quick sketch here. So you have your 3 zeros. The other thing we need to know is the end behavior and the behavior at the zeros. So the end behavior for this one is going to come from the degree and the leading coefficient. The degree is odd and the leading coefficient is positive, so it's going to go up to the right. So the end behavior is going to be down, up, and every zero in this case was a single root. We didn't have x minus 1 squared or 3x plus 7 squared or anything like that. So there's nothing crazy happening there. So we're just going to go right through. And that is our quick sketch. We didn't stress about the location of the y-intercept. If you were asked to actually graph something accurately, so if it was a test and I gave you actual numbers on the graph, then you want to be careful about where this crosses the y-axis. But since it's just a quick sketch, we just wanted the overall shape, and we have the overall shape here.